Welcome back. Today we're going to be looking at 2.6, proofs of known facts. You're going to need your booklet, a ruler, a pencil, and got it? Great. Let's get to work. Let's read this carefully with each other. Once a theorem has been proved, it can be added to our list of known facts and used to prove other theorems. For the list of known facts that we've been working with in this class, take a look at the list of angle facts on pages 35 to 38 of your book. In lesson 9, which we called 2.5, we proved that vertical angles are of equal measure. And we know from earlier grades that if a transversal intersects two parallel lines, alternate interior angles are of equal measure. How do these facts help us prove that corresponding angles are of equal measure? So if we take a look at this right here, let's actually just draw them out. So if I have a pair of parallel lines right here, and I draw a line through them, kind of like what we might have set up down here. If I wanted to prove that corresponding angles are congruent, like here and here, and I know that alternate interior angles are congruent, this key idea of parallel lines might be really, really helpful. So let's look at this in terms of the way the problem is laid out here. In the diagram to right, you are given that AB is parallel to CD. How can you use your knowledge of vertical angles and alternate interior angles to prove that X is equal to W? Well, let's lay out what we know. We know that by vertical lines, X is equal to Y, and W is equal to Z. And this is because they're vertical angles. And we know by alternate interior angles that X is equal to Z. Alternate interior angles of parallel lines, and that's important. Now, how do we then in turn use that to say that, well, let's think about this. If X is equal to Y and W is equal to Z, how do we then, and X is equal to Z, then we have a bridge, right? We can say that if W is equal to Z and X is equal to Z, therefore X must be equal to W by substitution. Now this is not a formal proof because I haven't laid it out in two columns and given it out, but it clearly has all the elements necessary. It has all the steps listed, it has reasoning for each of the steps, and now it means we can now use that corresponding angles are always equal in measure for any further proofs. A cool moment to just take a quick side trip. One of those really famous Greek guys that we hear about in geometry, Eratosthenes, the one who also created the first sieve to find primes, he was able to discover the circumference of the Earth without cell towers, satellites, or any advanced instruments, were just eyes, his feet, and perhaps the ancient Greek equivalent of a protractor. Take a look at the link here to figure out why, how or why. But before we do that, I'm going to help you set up this practice that we're going to spend most of class working on today. Construct a proof designed to demonstrate the following. If two lines are perpendicular to the same line, they are parallel to each other. So step A, draw and label a diagram. So I'm going to need my ruler, and I'm going to need to draw one perpendicular line. Now notice I'm drawing, not constructing. In a more formal sense, I would have to construct using a compass these lines right here. Okay, so these are parallel. And I want to say this is my 90-degree angle, and I'm going to label this angle X because I don't know that they're yet parallel to them. What do I know to be the truth? Well, if I label this Y, I know Y is equal to 90 degrees because it's a right angle. I also know that X is equal to Y because they're corresponding angles of parallel lines. Therefore, I can say X is equal to 90 by substitution. And if X is equal to 90, Well, there's only one type of line that creates 90-degree angles. And that, my friend, is perpendicular. Therefore, and now we're going to add one label, this line. So line L has to be perpendicular to AB, because I can label it L for the line, or by the points AB, because the intersection forms a right angle. And that's like the little abbreviation for right angle. You make like a little mini picture of it, like a little right angle with a little box. And now I can write 1, 2, 3, 4. There's my proof. Notice I'm writing out my reasons for each step. That is the key part. In class today, we're going to be investigating this proof right here in pairs, each of us taking turns to persuade each other it's the case. It's also valuable for you to take a look at the exit ticket right here to think about how you would attack that, because that's what we're going to be spending the second half of that class on. I want to wish you, looking forward to seeing you all your great work. Wishing you a wonderful rest of your day.